Greetings of the day, sir. Myself Hitarth Agrawal from class 8th. I am from Kisan International School. I have been working upon the problem number 1, inventing yourself. Uh, This is the solution report PPT for the same problem number 1 required for round 2. I will be explaining you the PPT in short, and the same PPT will be shared to you on Google Classroom. So let's begin. So first we will see the approach. What is the approach? So we will be understanding the problem statement. Then phenomenon observation. Then we will be observing the phenomenon and see what the phenomenon is willing to say. And then we will be explaining the phenomenon. Then we will be asking some questions on the basis of the phenomenon. Then we will be designing and conducting relevant experiments required. Then we will be formulating a theoretical model on the basis of that. Then we will be comparing the theoretical prediction and experimental results. And then at last, we will be forming the conclusions. So let's begin. Let's begin with the problem statement. So let's see what the problem statement says. Take a box, example a matchbox, filled with identical objects, example matches, balls, etc. Find a method to determine the number of objects in the box solely by the sound produced while shaking the box. So in short, the problem statement says that we have to find a method to determine the number of objects in the box by the sound produced while shaking the box. So the main material which we used in our experiment was matchbox. So the matchbox was acted more or less as a whole system. It was used as a small container in which all the objects were placed. So this helped a lot. Identical objects. The identical objects that were used were different types of matchstick, like small plastic matchstick, tic tac, and a large wooden stick. With the help of these, we plotted different graphs and compared sound produced. So it helped a lot. The properties of objects, the objects we mainly used were made up of wood for large wooden stick, plastic for small plastic matchstick, and tic tac, which was a food grade material. All of these easily produce sound on shaking them. So why these types of materials were only choiced to do the experiment? So the answer to this question would be these types of materials were chosen to make more accurate and better results and to make further conclusions. Next. Now, what is the packing density? What do you mean by packing density? So answers to these questions would be, in simple words, it is the ratio of the solid volume to the total volume in any substance or container. So in our experiment, it would be the ratio of the matchsticks, which is the solid volume, to the total volume, which is the volume of container. Now, what is the methodology we used here in the experiment? Let's see. First, filling the matchbox with different types of matchsticks and tic tac. Second, checking the sound produced by matchsticks by changing its number frequently with the help of sound analyzer website. Third, few trials were done by changing the size of matchbox, like small size matchbox, medium size matchbox, and large size matchbox. So, fourth, plotting graphs to compare the sound produced by different types of matchsticks. Fifth, finding a proper and accurate method to determine the number of objects in the box solely by the sound produced while shaking the box. This is with the help of analytical equation. Now, one by one, I will be explaining you the methodology we used. First, filling the matchbox with different types of matchsticks. So, we filled the matchbox with different types of matchsticks. First, small plastic matchsticks, as shown in the figure A, tic tac, as shown in figure B, and large wooden stick, as shown in figure C. Then, we checked the sound produced by matchsticks by changing its number frequently with the help of sound analyzer website. After checking that, we got three different cases as follows. Empty box, no matchsticks in the box. That means only air is present in the box, no matchsticks is present in the box. Second case, box completely packed with matchsticks. That means no air is present in it, only matchsticks are present. And the third case, 5 to 6 matchsticks present in the box. So one by one we will be checking the cases. So for better understanding, I will be playing the below video.
So as you can see here, here you couldn't hear any sound as there was an empty matchbox, and as I told you earlier that there was only air present in it.
Now we will move on to the second case. Box completely packed with matchsticks. I will play the video for better understanding.
Second case. In this case also sound was not produced as there was no medium to travel. As you can see, it is completely filled with completely packed with matchsticks.
Now we will move on to the third case. 5 to 6 matchsticks present in the box. I will play the video for better understanding.
The third case. The sound was produced with a longer waveform and the louder sound was there. This was due to 5 to 6 matchsticks were present.
I hope you have understood the 3 cases which I got by the sound produced by different types of matchsticks and boxes. So now, after that, few trials were done by changing the size of matchbox. So we took different size matchboxes like small size matchbox, medium size matchbox, and large size matchbox. As shown in the figures, this is the large size matchbox, this is the medium size matchbox, and this is the small size matchbox. So we after that we plotted graphs and comparison of sound produced by different types of matchsticks. So I will be now I will be showing you the different types of graphs we have plotted on the basis of sound produced. Graph number 1, medium sized matchbox versus small plastic matchsticks. Graph number 2, large sized matchbox versus small plastic matchsticks. Graph number 3, small sized matchbox versus small plastic matchsticks. Graph number 4, effect of different matchsticks. The same is shown in the graph with the help of different colors for different types of matchsticks. Graph number 5, medium sized matchbox versus tic tac. Graph number 6, effect of different type of matchstick. As you can see, it is mentioned with different types of colors for each matchstick. Graph number 7, small sized matchbox versus tic tac. Then, after the graphs were plotted, we found a proper and accurate method to determine the number of objects in the box solely by the sound produced while shaking the box. We tried experiments with different objects as well as different quantities, as we saw earlier. We studied the effect of sound with available medium. We plotted graphs for different sound levels. The same was correlated from theoretical equation along with the graph. So this is the theoretical equation which the previous researchers have formulated, and the same I have referred. Then now I will be describing the experiment. In order to achieve higher accuracy, we decided to use Sound Amplifier website, which gives near to accurate results of sound level in decibels and also in graphical form. It records the readings from 20 decibel to 80 decibel. All trials were done until the sound dropped to a magnitude of 40 decibel. Trials were done by increasing matchsticks by a step size of 4 sticks. 3 trials were taken for each N and the average value was considered. We have in addition performed experiments to determine if the shape of the matchsticks themselves have an effect on the sound produced. The experiments were then repeated for filling up the matchbox with different matchsticks. Now, let's see what is the theory. We have applied dimension analysis to try and figure out the parameters that affect the sound and how they relate to the number of matchsticks inside the box. We expect a bell-shaped curve for the plot of number of sticks versus sound produced. As you can see the equation. In the above equation, Pi refers to the pressure difference created when the walls of matchstick vibrate and thereby produce sound. As we know that when the particles inside the matchbox will collide to the walls of the matchstick, therefore then only the sound would be produced as the energy would be released. So thereby they produce sound. So this pressure difference is assumed to be directly proportional to the number of matchsticks. And this proportionality represents the volume of air inside the matchbox. Since sound needs a medium to travel, the air enclosed needs to be considered. Since the sound cannot increase monotonically as a function of number of matchsticks, we expect a peak sound corresponding to a certain number of matchsticks after the sound will decrease. That means the sound will first increase and then start decreasing gradually. So this is easy enough to verify since we had saw the three cases earlier, that one with no matchsticks in the box, second with box completely packed with matchsticks, and third with the 5 to 6 matchsticks were present. So this special number of matchsticks will be a combination of both pressure difference as well as a volume, and we expect a Gaussian curve or bell distribution for the same. So now what is the Gaussian curve or bell distribution? Answer to this question would be Gaussian curve, also known as bell distribution, is a bell-shaped curve. It means that it looks like a bell. And it is assumed that during any measurement, values will follow a normal distribution with an equal number of measurements above and below mean value. So here, this is the mean value. So above and below the mean value, there will be equal number of measurements. Now, we will be asking some questions on the basis of the phenomenon. First question, is the phenomenon dependent on the quantity of object? Yes, of course, the phenomenon is dependent on the quantity of object, because by changing the quantity of objects, a difference in the sound produced was observed. Second question, what inference do you derive from this study? Now we can derive the inference from this experiment that medium is a must for the sound to be produced. As we saw the three cases, in all the three cases, medium was present. Thereby, due to the medium, only the sound was produced. Question number 3. Does the result vary by changing the objects? Yes, the result, that is the sound produced, varies with the change of objects, because there is a difference in the density of objects. Now, as we know, the density is mass upon volume. So if we will change the objects, therefore the mass will also change, and therefore the density will also vary, and sound produced will also vary. Question 4. Is there any method to build correlation between subjective and objective analysis? Yes. Researchers have found out below this equation, which can build correlation between subjective and objective analysis. Question 5. Is it possible to have graphical representation of the results? Yes. The results have been plotted in graphical or waveform with the help of online software. As we saw earlier, 7 different types of graphs were plotted. Now we will be comparing experimental results and theory. So as we saw, the researchers have found out below equation which can give accurate number of objects used to produce sound. The same sound can be obtained by experimental result in graphical or waveform. So this equation, as we saw earlier. However, to work out this, so we need to find out the variables, right? So the actual values of variables cannot be found at home, right? So all these measurements need a special calibrated equipments or a well-established laboratory along with anechoic chamber. So now what is anechoic chamber? Anechoic chamber is a special designed chamber or room in which the echoes or the sound is blocked, or electromagnetic waves are blocked. So hence, at this stage, with lack of above testing facility, exact comparison between experimental results and theory has not been established with actual results. Now, the conclusion. So now with these experiments and theory, everything, we learned the following things, and we have concluded the following things. First, medium is necessary for the production of any type of sound. As we saw in the three cases which we got. Second, sound intensity varies with the number of objects in a given container. Also, the sound varies with the type of object used in the container. Third, Frequency is not a property of number of matchsticks. It only depends upon material of matchsticks, just like friction. As we know that friction depends on the nature of surfaces in contact. So same as that, frequency also depends on the material of matchsticks. Fourth, frequency depends on the material but is independent of the number of sticks replaced. Fifth, number of matchsticks influences the loudness, as we saw earlier. Sixth, amplitude is lesser when distance is greater, and amplitude is greater when the distance is lesser. Seventh, the amplitude is lesser when the force is lesser, and the amplitude is greater when the force is greater. Now, as we can understand from this, like while shaking the box, if greater amount of force is applied on it, therefore the sound produced will also be increased. Like amplitude would be greater, and if the sound force is applied less while shaking the box, therefore the sound will also be less, and the amplitude will be also lesser. So therefore, it's the same case with the distance. So with my sincere hard work, I presume that you will appraise my sincere efforts towards the project. Thank you.